Hi everybody, Trevor Williams here, and thank you for joining me in this tutorial where we will be going through building a multi-tenant solution using ASP.NET Core and Postgres. This is a snippet from a more extensive course called ASP.NET Core Development with Postgres and Azure, and you can enroll using the link in the description below. But for now, enjoy this tutorial and I'll see you in the full course. So I'm going to be using Visual Studio. Let us create a new project and we're going to be building out our demo using ASP.NET Razor pages. If you just search for ASP.NET Core in all of your templates for the projects, you'll see ASP.NET Core Web App Razor pages. I have other courses where I've taught like API development using ASP.NET Core as well as MVC development. Select that template. And then we're going to be calling this neon.crm.webapp. Hit next, confirm the framework that we're using, use the latest .NET Core versions installed. We can also include the individual accounts so that we have authentication out of the box. We will keep HTTPS, we don't need container support, and everything else can stay as is. And let's go ahead and create the project. Now we want to add entity framework to our project. Now I'm using the NuGet package manager, which when you right click on the project, you'll see manage NuGet packages. I'm looking for entity framework core. I'm going to get several search options. Now the ones that I want to target, Microsoft.entity framework core.design and the tools. The tools will give me the ability to perform certain commands. Since I am using Visual Studio, you don't have to add tools if you're not using Visual Studio. You'll also notice that we already have some of these installed because we opted to keep identity, and the default database for Microsoft products would be Microsoft SQL Server. So we have the package here for Microsoft SQL Server. However, for this course, we're actually using Postgres. So I need the Postgres extension of Entity Framework Core, and that needs to be installed. So I'm going to go ahead and do that. Now that we've added the new packages, we can go over to our program.cs and we'll see here that we are registering the application DB context. Now, the great thing about Entity Framework Core is that we don't have to change this code just because we're changing the database. The only thing that I need to change now is to say that I'm not using SQL Server. Instead, I'm using something else. But you see here that it's trying to get the default connection from the app settings.json, which is this. And that is a connection string to a Microsoft SQL Server database. I'm not going to remove it. I'm just going to add a new line or a new connection string, which we don't know yet because that connection string will point us to Neon. But for now, I'm just going to call it Neon CRM, Neon CRM connection string, but it's going to be blank for now. So I accepted that suggestion, but I'm just going to make an adjustment here. Connection, yes, Neon CRM connection. And then change the connection string to point to Neon CRM connection. And then when we're adding the DB context here, I'm going to choose to use NPGSQL. So this now will take the same connection string and any other options that I want to define, which at this point I don't have any. So I'm just showing you that we started off pointing to an SQL Server database using EF Core. So now that we've had PostgreSQL added to our project, when we come back, we're going to define our database models. Now we need to add some code to support our data models. So in our data folder, I'm going to create a new folder and I'm going to call this models, and then add some classes. So a data model is really just a class that represents some entity or some database table. Now, the first data model I'm going to define would represent the agent. So this is a system for agents, and the agent would actually be a user. So all I have to do for the agent to be a user is inherit from identity user. Identity user is the built-in user class given to us by Microsoft.core, Microsoft.ASP.NET Core.identity. Identity user comes with certain default columns, and what I'm going to do is add more columns. And what we're going to have is an agent with all of the identity user properties, a first name, last name, and you'll see all of those fields later on when we're building out our application. The next one that we're going to want is customer. So we're going to have public class customer. Now, customer is not going to inherit from anything. Now, pay attention to ID here. With EF Core, once you have a column or a property in a class rather called ID, or if you make it an addendum between the entity name and the word ID, it will automatically be the primary key when Entity Framework Core sees it. We want an email address, a phone number, an address. So we have agent and we have customer. Now, the thing is that agents will have their list of customers, right? So we need some way to tie them together. In database development, we know that to be a foreign key. So what we're going to have in customer is some reference to the agent ID. So I'm going to have two things. The first one is a navigation property. So it's a property of type agent to show that we are relating this to the agent. And I'll make this nullable. And then I'm going to have the actual foreign key field, string agent ID, and that can be defaulted to string.empty, or I can make this a nullable string. Now, why am I making this a string where generally speaking the ID is an integer or a GUID? Well, specifically agent, which we didn't define an ID for explicitly, is inheriting from identity user, and identity user actually uses a string ID. The customer has a foreign key reference to the agent, but in the agent we can also create a navigation property that goes to the customers. And I'm going to initialize this to an empty array. So we're going to have this public collection of customers, and this just represents the list of related entities. And pretty much in AF Core, that's all you need for a relationship. We have a one agent to many customers. Each model gets its own file. So now that we have our models defined, we need to let the application DB context know about them. So our DB context is that, let's say that's the unifying file that represents the current state of the database. At present, because it's the default one, it started off by inheriting from identity DB context. Now, because we changed the default identity user type, I have to now tell this that it is to use agent as that default type. Next up, I need to include what we call a DB set, which is what defines each table. So notice now I said public DB set of type customer, but I'm calling the table customers. Now this is up to you and your database naming specification. Some persons don't pluralize, some people pluralize. I like to pluralize. So even though the entity is singular, the table name is always plural whenever I do this. We don't need to do that for the agents because the agents are actually just an extension of the default user table, which is already there. So I don't have to have a whole DB set for something that's already there. So whatever user type you have, you don't need a DB set for it once you're inheriting from identity user. So now we need a new migration. I need to point out is that migrations are specific to the database they were designed for. Remember that the project started off using an SQL Server database, and now we're switching to PostgreSQL. While EF Core is trying to be universal, the fact is that databases have different requirements. So this initial migration is useless. So we remove this entire migrations directory, and then I add migration. So our migrations directory, albeit in a different area, we did get a brand new migration file. It is doing the same thing, but now it's making sure that it's doing it within the context of the PostgreSQL. All right, so we went to https://neon.tech. From here, you can go to login, and I'm going to log in directly because you can always connect using one of these SSO providers, or if you want to use the traditional username, password, or email password, you can go and sign up. Once I have verified my identity, they're going to ask me what my project name is. So I'm going to say Neon CRM. They are fully supported in AWS and Azure. So for your business needs, if you're already in either of these cloud hosting platforms, you can directly access the service there. The best region for me is East US 2, so I won't have to change that, and we can create our project. Once our project is created, we get this dashboard. We're allowed to have up to 10 branches in this project, and all of this is for free. So we can look at our branches. So if you're familiar with Git, you know that you're going to start off with main or master. Then from that, you can create branches and you can merge. So whatever it is you think of with Git and branching and merging during application development, that is possible here at database development, which is a great advantage because there are times when we need to experiment and we don't want to do it on the database that everybody is using or on the staging or production. So you can always branch off, do what you need to do, your validation, and then you can merge back in. The next thing we want to do is actually let the application know about the hosted database before we can perform the database update. So in app settings.json, we need to actually provide the connection string here. So if I go back over to Neon, I can click connect here and I can actually choose the connection string. I can narrow it down to the platform I'm using or the framework I'm using for development. I have to show password to see the full thing. So I'm going to copy that text and jump over to Visual Studio, paste that there. Bear in mind, connection strings, I have all the information that anybody needs to access a database. So it is generally recommended that you use secrets to store sensitive information like this or an environment variable in your hosting environment. You could use secrets to add the connection string to your secret store, but then when you deploy, you're going to have to look into another type of application like a key vault or a secrets manager to then retrieve the secrets on the fly. For now, it's okay. Now that we have our connection string and everything defined, let's jump back over to our package management console and write update database. You'll see a message that says done. If I go over to the Neon console and go to tables, then I will see NeonDB and several tables. So let's take some time to understand what multi-tenancy is. Now, multi-tenancy is a software architecture where a single application instance serves multiple customers or tenants. Each customer or tenant's data should be isolated and secure, and this is a common approach to building SaaS or software as a service applications. Now we can get started with the implementation of the service client to communicate with the Neon API. In services, add a new class and call it Neon Service. Now type ctar and press tab to autocomplete that. And we're going to be injecting the HTTP client service as well as the configuration. We'll have seen the configuration injected from when we were doing the email sender. Then I can use control dot and create and assign two fields, one for the config and one for our HTTP client. I prefer to name my fields with an underscore. Now, our HTTP client, we need to set the base address. So HTTP client.base address is going to be coming from our config, and I'm going to put that base address in the config under a section called Neon API, and we'll call it the base URL. The next thing that I want to do is add the default request header. So to access the API, we actually need an API key or some form of authorization. So we're going to go and retrieve that. So we're adding the authorization to be a new authentication header value. This is going to also come from our Neon API config section, and we're going to be calling that API key. To get the API key, go to your emblem in the top right hand corner, go to account settings, and if you scroll down, you see your API keys section where you can create one. Create a new key, give it a name, and I'm just going to do another one while we're here. Create, and it's only available one time. So copy it, store it somewhere safe, and then use it in your code. I started putting together the app settings that are needed for the service. And I have a whole section here that I'm calling Neon API. The API key is present, and that is what will be used to be injected into the authorization header. The next thing that you need to know is your base URL, which if you go over to the API reference documents, you can retrieve that easily here. That is base URL. The project ID and parent branch IDs, those are fairly easy to find. We had discussed that the project ID is actually present when you go to projects and select the project, and you can either take it from the URL right here, or if you're not comfortable with that, you can always go to manage and you can copy that value here. We'll go to branches, and then we find that main branch, and then we use that ID. Going back to the API docs, before we start writing code, we need to know how the endpoints work and which endpoints we need to further our goals. If you look, you'll see a branch section, and the first thing here is create branch. Now, here's the URL that we're expected to call, and it's a post request. Let me just walk you through some of the required fields and what the request body looks like and what the response body will look like. So the required fields, project ID, we know that. The endpoints for this section, we need to provide a type. Now you can say read only or read write. And then by adding this section, you get this array section inside of that object, that request body object. So that is what we are sending over for our endpoints section. Then we have the branch section, which is an object which requires the parent ID. So the ID of the parent branch, which in this case will be main. And we need the name of the branch. So I'm just using my branch. That's a sample, but that will be that tenant name that we're going to provide. And notice the length restriction is 256 characters. Finally, the init source. Init source can be schema only or parent data. We saw that earlier when we were looking at how branching works. In this case, we want schema only because we don't really want to copy the data from the main branch every time it makes a branching decision. These are definitely the parameters that we want. I plug these in, I sent the request, and this is what that curl request body looks like. And here is that data object, which is, we can use that, we're about to use that. And then this is what that response body may look like. Very detailed response, giving us a lot of information. And we actually get that connection URI that we can use to form out that connection string on the fly when this new database, this new branch has been provisioned. Just to wrap up this exercise, what I'm going to do is copy this section that represents the request body. And this is the minimum that we need to send in order to create the branch and get this information. I'll just take that JSON body, and then inside of our service class, I'm going to go to edit and go to paste special and paste JSON as classes. You can always go ahead and convert the JSON into C# classes using online tools and then just copy them over if that is easier for you. Now the default class I got is root object. I'm going to say branch create request. This is our object that we're going to use to fill out the branch information and the endpoints information at minimum when we're submitting that request. Put these in another file, create a type called branch create request, and then to move these two classes into that same file so that everything is one place. So all of those are needed for branch create request, and that is in the namespace. I'm changing the namespace here for the purpose of avoiding clashes, because when we look at the payload of the response, you're going to see that there is a section called branch, which is going to clash. Go ahead and copy this whole response to create another class and call it branch create response. And I'm going to change the namespace here to say response, make it scoped, and then paste special. I want this to be branch create response. Now we have the different class models that we know are going to be involved in that creation operation, the request and response. Now we can start by creating a new method, create branch async. It's supposed to accept a tenant name. We're going to define that project ID. We're getting that from our config section. Then we can define the request body, and it's going to be of type branch create request. We have branch, and branch is going to have parent branch ID. The name is the tenant name, and I'm going to interpolate tenant underscore and make this lowercase. All right. And then source, next we need to define the endpoints. This is going to be equal to a new array of endpoints. And the type here is read underscore, right? Now you'll see here that there's an ambiguous reference here. So I'm going to make sure that it's clear that I'm using the request endpoint namespace for this class. So this is how we're making that payload or forming out that JSON payload for the request. Next, we need to make the request. So I'm going to say var response is going to be equal to, and we'll let the HTTP client make a post request to projects / the project ID that we defined here and branches. And that is indeed the URL that we need to request. So we already have the base URL configured in the HTTP client, projects / that unique ID / branches, and it is a post request. Now that method is going to give us a response. I do want to see if it is successful or not, what happens. So what we're saying here is if it is a success code, then we can retrieve the branch create response, which I need to add the using statement for that. So that is the second set of classes that we created in the previous session. And then we're going to return the branch response.branch ID. Well, that's the suggestion. I actually want to return the whole response. And I think that suggestion is because I indicated string up top here. So let me change that response type. And then I'm having another ambiguity issue here with branch. So I'm going to make it clear that I'm using the request branch type. So we're returning that entire branch response. This is saying it might be null, but in my mind, if it is successful, then it won't be null. Otherwise, we want to throw an exception and look at the response.reason phrase, maybe not the reason phrase. I actually want to see the content.read as string, and we'll await this so that we actually get the JSON body that would outline what the error is. Now extract interface here, and that's just going to create an interface file and now register it as a service in the program.cs, and you'll see that I've done that here. So we add the HTTP client neon service, and we're adding it as a typed client. Now we can move on to starting up our automation for provisioning in our registration page and process. So I've gone over to the register.cshtml file, and I've already injected the iNeon service, and we know how to inject and set up our read-only field to be initialized inside of our constructor. So go ahead and do that. We want to modify the registration process. On post, we're going to validate the data coming in, and once it is successful, then we go ahead and send them a confirmation email. Now in a real life scenario, you may want to do the provisioning after they have confirmed, because if your system is free to use by third parties but you are incurring expenses, then you want to make sure that you don't incur additional expenses when somebody's experimenting. Now this needs to happen in the main database, and user manager is already wired up to look in the application DB context. When we added, or when the system added default identity, it already wired it up with the application DB context. So that now means that I need another DB context that will represent these tables, and that is going to be provisioned on the fly based on the user's connection string. Being shorthand, I'm just going to right below this define a new class, and we're calling it tenant DB connection string, and then it's going to take these options, and well, we don't need the unmodel creating. So now that we have defined the class, let's define a new class. This one is tenant DB context factory, And in here, I'm going to have a method that is going to create. I'll just remove the static, but this is going to create based on the passed in connection string. Basically, it is defining this options builder here, because that's what these options are. And these options get passed in at startup to the receiving DB context. Now, we're not doing it at startup. We want to do it on the fly. So we have to define that option builder manually. And then we're going to tell it use npg_sql and initialize based on that connection string. And then we're going to return a new instance of this DB context and options with options. So that's what our factory will do. Next, I want to register this factory as a service. So in program.cs, I'll register it and I'll just do it underneath that neon service. So we'll say builder.services add scoped, and we're passing that DB context factory class that we just created. Our objective here is to configure how we can dynamically access the connection string without relying on going to the database every single time to find out what connection string should be used for the logged in user. So create a folder, call this providers. And in providers, I'm creating a new class. This is going to be a custom user claims principal factory. Let me make this scoped. This factory is going to extend our user claims principal factory. The idea here is that anytime somebody's logging in, they create what we call claims. Claims are bits of information, your email address, your username, and there are times when you want to add more information to the claims than the default information. Generate claims async gets called automatically by the sign-in manager. However, we're overriding it because we want to capture the claims that actually get created, and then we can now put in our own custom claim, the tenant connection string. The value would be coming from the actual user record and the field or property, tenant connection string. At the end of this operation, it's going to return the actual claims identity. So now when we access the claims after login, this and any other information that you add in a similar fashion will be available. And if you want to learn more about this, you can check out my course on identity management in .NET Core. I go in depth and I show you how you can override a lot of those operations and make them your own. So now that we have this new claims identity provider or factory defined, I'm going to have to register it in the program.cs because of course the application needs to know that there's an extension. So we're going to say builder.services.addScoped, and we're adding the user claims principal factory relative to agent, but we're letting it know that we're extending it with our custom user claims principal factory. So that's like a nice extension or nice way to extend the default sign-in manager functionality. So now this claims information is accessible to us through a mechanism called the HTTP context. So this HTTP context is present every time there's a web request, and it actually has all of the information about the web request, where it's coming from, where it's going to, which user, and most importantly, the claims of said user. So firstly, we can add the HTTP context accessor to our services, and then that lets the application know that, well, different services should be able to access the HTTP context. Now, what's the relevance of that? Well, it now means that in my DB context factory, I can inject that HTTP context accessor, and then through that accessor, I can now retrieve the user, or at least user here represents the set of claims. So the claims, including the connection string, will be included in that request. So I don't need to ask for the connection string every time I'm creating a DB context. Instead, now I can actually say that I want to find the connection string value from the list of claims. So I can now say var connection string is equal to user find first tenant connection string value. To go ahead and build the connection string. So once a user is logged in, then they have that claim, and that's how we can dynamically retrieve that connection string and generate the DB context.